Yeah, welcome to today's lesson. In this lesson, we're treating the state of matter, that is solid, liquids, and gases. So we first start by an introduction. So what matter is? Matter exists as three principal states. So when you hear the word matter, they're actually talking about solid, liquid, and gases. And these states are defined by distinct properties, which include the shape, the volume, and arrangements of particles. So when we hear matter, we should always remember solid, liquids, and gas materials or particles. So these particles can only be distinguished based on the way their particles are arranged and based on the volume, the way their volume behave, and also their shape. So understanding these states of matter forms the foundation of study of chemistry, and it helps in explaining various phenomena in both natural and experimental context. So we'll be dealing with solid matter now. So solids are characterized by closely packed particles arranged in a fixed and orderly manner. So when you talk about a solid, you'll be talking about a particle which is atom are closely packed. They are held together tightly. So they are not free to move. They just stay static at a position. So this static motion, this ability for them not to move, this inability rather for them to move, is what is responsible for the definite shapes of solid. Solid, we know solids like metals, some kinds of wood, just even ice. Solid materials are materials that they don't, if you touch them, they don't really move. Like they don't change shape. Yeah, that's the best word. So they have a definite shape and volume because the particles are only allowed to vibrate at a fixed position. So, as I said initially, they just vibrate. They don't really move. They just stay at a point. They are static. So, the only type of motion that the particles or the atoms undergo is vibrational motion. So, they just vibrate at a single spot. So, this structure gives solid their high density and incompressibility. So, example of solid that I was saying initially, we have metals, ice, and wood. So, now let's move on to liquids. Liquids, they are a kind of matter that have no fixed shape, but they have fixed volume. So their volume is definite. They have definite volume, but they don't have a specific shape. So they take the shape of whatsoever container that they are being contained in, and they have the ability for their particles to move past one another while being relatively closely together. So what happens in liquid is this: the particles, they are held together by just internal force of attraction. So their particles are holding themselves, but they don't restrict themselves from moving about. So they can easily move across along with themselves. They can roll over each other. They can roll over each other, but they don't really leave themselves. They don't really leave themselves. So unlike solids, their particles hold them together, and also the environment also holds them together. Like the kind of forces that hold them solids are both intermolecular force of attraction and also the shape, the molecular force of attraction. So unlike liquids they can roll over each other, as I said initially, and they can move, but they cannot. Their particles are not free to just move anyhow. So this is the reason for their definite volume, and also they don't have fixed shape. So these intermediate particle arrangements allows liquids to flow and make them less compressible than gases. So liquids now we can see that, as I said liquid have a stable volume. They have a definite volume. So meaning when you have 10 liters of water, if you pour it in another container, maybe a wider container, it will still retain that same 10 liters of water so long as nothing spilled off. So, but gases, when we get to gases, you see how these particular characteristics distinguish liquids from gases. So solids, we say solids have definite shape and they also have definite volume. However, liquids have no definite shape, but they have definite volume. So now let's move over to liquid. So before I move over to that, we said that we have examples of liquid. We know examples of liquid: water, oil, alcohol, mercury, and some other stuffs. These are liquid material. They move freely, but they don't they don't change volume. That's the simple word for it. They don't change volume, but they have no definite shape. They change shape, but they don't change volume. Let's move on to gases. So gases don't have definite shape, neither do they have definite volume. So the particles are free to move apart. So unlike in liquids where there's some kind of forces that hold them, in gases, there are no force of attractions between the particles of gases. Each of them are free to move as far as they can go, as far as they want to. So their particles are far apart and they move rapidly in all directions. So this leads to a low density and high compressibility. So for solids, we say solids have very low compressibility. You will hardly be able to compress solid, meaning to press a solid, like to hit, like make a, if you see sheets, when you want to make a solid into a flat surface, you will need to hammer it with so much energy before you can compress its size. However, for liquid, just let it flow, it will compress by itself, it will relax on its own. Even if you keep it on a straight container and you allow, just let it be, it would relax and to always want to flow. So that's what they mean by compressibility. So liquids can easily be compressed compared to solids, while gases, they have they can be much more they can be highly compressed. I mean highly compressed because they don't have definite volume. So solids have definite volume, so they have low compressibility. Liquids have specific volume, so their compressibility compared to solids are better off. They can be compressed better than solids. However, gases, they can be highly compressed, so you can reduce. You can see maybe a gas initially the container was a 10-liter container. You can press the container to become maybe 5 liter, and the gas will still remain inside that same container. Unlike liquid, if you have a 10 liter of water and you're trying to compress the water inside, the body of the container would swell up, but it will be difficult to actually compress the liquid. That's just the idea. So gases completely fill their container and expand or contract depending on the pressure and temperature. So examples include oxygen, carbon dioxide, nitrogen. We also have ammonia and their likes. So for physical changes between these states, so there are these different states of matter, they interchange between one another. So you can move from solid to liquid to gas and so on, either ways. So now these are the names for these movements from one state to another. So for solid to turn into liquid when temperature is increasing is known as melting. So we all know that one. When ice block change from solid to liquid due to the effect of temperature, it is called melting. But also for liquid to turn solid, that's the reverse, as a result of temperature change, it is called freezing. So for condensation is when gas is turned to liquid. So when you have a gas vapor and you turn it down, you bring it, compress it, condense it rather to liquid, it's called condensation. So this is when liquids cool down. So when gases calm down and they convert from gas states to liquid states. So evaporation is when liquids turn to gases. So that's the reverse of that. When you see a liquid moving from its liquid states going up into gaseous phases. So they are known as, that process is known as evaporation. So there's also a phase that is known as sublimation. So this is like an intermediate phase between these. So we have solid, liquid, and gases. So when we move straight from solid directly to gas, it's called sublimation. It's called sublimation. So, but when you move from solid to liquid, it's called melting. When you move from liquid to gas, it's called evaporation or vaporization. So, but when you move now backwards, now gas to liquid, it's called condensation. Liquid to solid, it's called freezing. So, but when you skip phase, going from solid straight to gas, it's called sublimation. So let's move on to what we have above. Before we go on, he said these changes are physical and reversible. So from what we can see, they are reversible and they are driven by temperature and pressure without altering the chemical identity of the matter. So in summary, solids have fixed shape and volume. Liquids have fixed volume but no fixed shape, while gases have neither fixed shape nor fixed volume. So each stage is defined by the arrangement of particles and also the energy. So whatsoever will determine whether something is going to be a solid or liquid, it has to do with its arrangement of particle and also the energy of the particles within the molecules. So when we go to the next topic, we will see how energy can actually be related to the shape of matter. So with that being said, that will be all for this lesson. Bye.